Okay, so we have question 5. It says sketch below is the graph of f of x is equals to a over x plus p plus q, having the domain negative infinities to 1, and then 1 is to positive infinity. So, okay, this basically means it's from negative infinity to positive infinity, where x should not be equals to 1 because that would be your asymptote. The graph of f cuts the y-axis at 0 is to 1. A line of symmetry of f is given by g of x is equals to x minus 3. Then we are given that graph there. 5.1 says write down the value of p. Now to crack the value of p, just simply look at your vertical asymptote here. So we see that the vertical asymptote is positive 1. But then remember, in order for it to become a positive 1 here, we need to take this and equate it, right? So that means your p-value here would have to be what? Negative 1. So if we say x and then our p, let's say it's negative 1, let's see if it's going to give us the vertical asymptote. Remember, how do we get the vertical asymptote? By saying x plus p equal to 0. So we are saying our p should be negative 1. So x minus 1 is equals to 0. Then our x is equals to 1, which would represent the what? The vertical asymptote. So in that case, that's how we were able to conclude that our p needs to be what? Negative 1. Because our vertical asymptote was positive, therefore p here would have to be substituted as negative. So note that trend. So 5.1, that's our p-value. Then determine the equation of the horizontal asymptote of f. Remember, we are given the line of axis of symmetry, and we know the line of axis of symmetry, that's where we have the intersection of those. That's where we have the intersection of those asymptotes, right? So this is the line that we are talking about. And if we can look at the point of intersection here, we can see that this point of intersection is with our axis of symmetry. So if we can use this coordinate here, that means we can be able to get the what? The horizontal asymptote. We use this coordinate 1, x is equals to 1, on which equation? On x minus 3. So we are going to say 5.2, we have g of x is equals to x minus 3. And then what do we do? So where there is x, let's substitute 1. You don't substitute negative 1, you substitute 1, the vertical asymptote, so that you can find the horizontal asymptote. So that's 1 minus 3. And then this will give us what? Negative 2. So that means the coordinates of the horizontal asymptote, or we are supposed to give the equation. So that's y is equals to negative 2. Right. Then we have 5.3. It says calculate the value of a. Calculate the value of a. Now we can see that since we have, so this is f of x is equals to a over x plus p and then plus q. Now we did calculate the value of p, it was negative 1. We calculated the what? The horizontal asymptote, which we do know that the horizontal asymptote is exactly the same as the value of q here. So what we got as our vertical asymptote was negative 2. So that means our q should be negative 2 as well. So now that we have that, we can use this coordinates that we are given here, 0 is to 1, in order to calculate the value of a. So let's use 0 is to 1 as our coordinates for y and x. So that means where there is y, f of x, I'm going to put 1. And then I have a here. Where there is x, I'm going to put 0 as that coordinate. And then what's my p value? It's negative 1. And then what's my q value? It's negative 2. I'm going to take this and transpose it over to that side. That's 1 plus 2, right? Now, 0, 8 divided by 0 minus 1. 0 minus 1 is negative 1. So this will give me negative a. So 1 plus 2, that's 3. And then negative a. If I swap these ones, my a will be equal to negative 3. Okay, so there we go. There we go. Right. Now 5.4. So this was 5.3. 5.4 says for which value of x is f of x greater or equal to 0? Now let's interpret this. What does this mean? It means where is our graph of f? At the x-axis or above the x-axis. So the meaning of this is we are looking for where the graph of f is exactly at the x-axis or above the x-axis. Now, let's investigate that. If we are to check this part here, we can see that our graph of f is actually below the x-axis. Let's first highlight the x-axis. So the x-axis is this blue line that I'm drawing here. Yes. So that's the x-axis. So we want where the graph will be above that point. Okay, so definitely not there. And then what about here? Is it above? No, it's below. So definitely not here. But then when we look at this part here, exactly, it is above the x-axis. So starting from which point? Starting from when x is 0 all the way to when x is just before positive 1. Remember, it won't touch, the graph won't touch positive 1 because positive 1 is what? Is an asymptote. So how should this be written? This should be written in this fashion, right? So, okay, this is not exactly at 0, pardon me there. So it is at this point here, which we should still look for, right? It is at this point which we should still look for. Then to look for that point, we can see that this point is actually a what? An x-intercept. So how do we calculate x-intercept? For x-intercept, we know that we have to make y 0. So we want to take this equation now. This is f of x is equals to, so let me erase here. So f of x is equals to negative 3 over x minus 1, then minus 2. So we are looking for the x-intercept. We make y 0. So 0 here, negative 3 over x minus 1, and then minus 2. And I take this minus 2 and transpose it over to this side. That's 2, and then negative 3 over x minus 1. When we cross multiply here, that's 2x minus 2 is equals to negative 3. Now this will be 2x is equals to negative 3 plus 2. Then we have 2x is equals to negative 1. Divide both sides by 2. Then our x should be equal to negative half, right? So that means the point here, the x-intercept that we have here is negative half. So it makes sense because we can see it's just a little over the origin here. So the origin 0 is here, and then this is just a little over there. Now, we said it's between this point and positive 1, but not touching positive 1. So that means the way we should be writing our answer is to say this is within x, an element of what? Square bracket, negative half. Why are we including the negative half? Because also at that point, it is exactly at the x-axis. Remember, we said the interpretation of this is that it must be at the x-axis or above the x-axis. So at negative half, we can see the graph is exactly stationed at the x-axis. So we want to have negative half all the way to what? To 1. But then when I write 1, I'm going to use what? Round brackets, because 1 should not be included into the critical values because it actually is an asymptote. Your graph will not touch them. Or another way of writing it is to say x here, and then greater or equal to negative half, but less than 1. So it's up to you how you actually want to write it. But then, yeah, that's how you were supposed to get that 3 marks there. So it's a mark for the x-intercept. So they gave 1 mark for the x-intercept, and then they gave 2 marks for your solution here. So 2 marks for your solution. Right, so 3 marks like that. Nice. Okay, right, then we have 5.5. It says graph F undergoes a transformation to H where the domain and range of H are the same as that of F, right? So they're mentioning that the domain and range of H would still be the same even if this transformation takes place. But then H prime X, which is the derivative of H, is negative on its domain, right? So they say describe a possible transformation that F could have undergone to result in H. Okay, so the range, let's start by the range of F. The range of H the range of f originally is what? So remember, we have our f of x is equals to -3, x minus 1, -2. So the range would be what? Y is an element of real numbers where your y should not be equals to -2, right? And then your domain of f would be x is an element of real numbers where your x should not be equals to what? +1, right? So this is what we have. Now, if we are to create an equation of h whereby we must still keep the same domain, so we're going to say h will be -3. So let me start by trying to reflect this along the x-axis. So I'm just doing trial and error here because most of the time, if this remains the same, it's a reflection along the x-axis. So that's -x and then -1. Remember, a reflection along the y-axis okay, so we say most of the time it stays the same when it's a reflection along the y-axis. So let's try reflection along y-axis, right? So that's -3 over x minus 1 and then -2. So what will happen here is that I would have to factor out this negative. So I'm going to have -3 and then negative bracket x. This one would have to be +1 and then -2. Now the negative and the negative will form a positive here. So we have +3 over x plus 1 minus 2. But note that this now changes the what? This now changes the domain because now the domain will be x element of real numbers where x is not equal to -1, which is no longer the same. So that means what would I have to do here in order that I still have the same domain? That means in order that I still have x minus 1 here. So what I can try to do is I can shift this 2 units to the right. Remember, 2 units to the right means I come here and say -2. And then this is -2. And then my h of x now will be what? +3 over x minus 1 and then -2. Right. So in that sense, that means if I reflect it over this side, then this becomes what? So it becomes something like this. Something like this. Something of this nature. Yeah. Almost like this. So there would be a reflection along the y-axis and then a shift 2 units to the right. Okay, yeah. Hope so. So, okay, how do I then define that? I would say this is a reflection along y-axis and translation 2 units to the right. Okay. You let me know your thoughts on how you were, how you could have answered that question. But then there are so many options. Even the memo gives a lot of options, about 4 options in which you can actually arrive to that answer there. So you can actually share which one did you use there to get that. So yeah, this question was open for a lot of methods in which you can use to land up to that. Right, so let's proceed to the next question.